Welcome to Spring LIB.
Okay, so we've been shown an aldehyde. And we've been asked to identify or draw an alkyne that, if it underwent hydroboration-oxidation, would give this aldehyde as the product. Sorry, I forgot the double bonds here. So an alkyne, here I've drawn a terminal alkyne with a methyl on one side, and I guess I'll say there's a hydrogen on the other, which undergoes hydroboration-oxidation, will become an alkene first, and that alkene will still have our methyl group on one side, but the other side will now get an OH, and specifically that OH will end up on the terminal side, or where the hydrogen used to be. And if you recall, if we allow tautomerization to happen, that so-called enols or alkenes with OHs coming off of them tautomerize into aldehydes, right? Which is telling us basically that this aldehyde used to be, via tautomerization, the same thing, but instead of being an aldehyde, it was an enol, like so. Okay, so hydroboration oxidation of an alkyne gave us this enol, and what did that alkyne look like? Right, so we've done this step backwards. Now we need to do this step backwards. And so basically all we have to do is say, well, this double bond would have been a triple bond, right? The double bond would have been a triple bond, and the OH would have been an H. So I'm going to redraw it one more time. Double bond would have been a triple bond, and it would have been straight because triple bonds are always straight. And the OH would have been an H. So drawing this with a little more space below, the answer, the final answer to this question, is this. If this alkyne underwent hydroboration oxidation, first it would turn into the enol that we saw, and then that would tautomerize into the aldehyde that they showed us.